Welcome to this explainer, everyone. I am absolutely thrilled to get into this today because we're looking at the hidden mechanics of nanotechnology. I know, it sounds kind of like straight up science fiction, right? But the way we actually engineer the invisible world really just comes down to a few surprisingly elegant rules of construction. So let's get into it.
Okay, let's dive into this. When we talk about nanotechnology, we aren't just talking about, slightly tiny things. We're talking about stepping all the way down to the literal basement of reality, manipulating matter at a scale where a single nanometer is just a few atoms wide. It's basically the power to rearrange the fundamental building blocks of the universe. So, at its core, nanotechnology is defined by direct intervention. It's a field that works by manipulating atoms and molecules directly. Simple enough definition, right? But the actual real-world engineering challenge is how exactly we manage to pull that off. Well, the source material breaks down two distinct, actually almost entirely opposite methods used to build the invisible: the bottom-up approach and the top-down approach.
All right, method one, the top-down approach, etching and breaking.
Think about taking a massive, solid block of bulk material and just forcefully cracking it apart. That's the top-down approach. It's exactly how we manufacture modern computer chips, by etching away layers of silicon using photolithography. We cut, we shatter, and we rigorously reduce the material step by step until only those distinct, incredibly precise nanoscale structures remain.
So, the crucial point is that this is entirely a reductive process. You start with a macroscopic, bulk material and relentlessly break it down into nanoscale pieces. And yeah, while it's highly effective, it inherently means you're carving away and discarding a pretty huge amount of bulk material just to reach those invisible fragments. Now let's pivot to method two, the bottom-up approach, building atom by atom. If the previous method was like violently sculpting a block of marble, this is more like organic chemical growth. Instead of a hard cube breaking apart, we start with solitary atoms, single molecules. We gently coax these fundamental pieces to join together, very much like how biology builds complex proteins or DNA. We're assembling them piece by piece into larger functional clusters.
And this brilliantly illustrates the methodical, sequential nature of this building process. Step 1, isolate the individual atoms or molecules. Step 2, assemble them one by one. And finally, step 3, build complete structures from those pieces. It is quite literally constructing reality from the ground up. And the best part? Absolutely zero wasted material.
So, two paths to the nanoscale. Let's compare the methods.
Let's move to a head-to-head comparison and see how this builds the ultimate contrast in engineering philosophy. On one side, the bottom-up approach, building by assembling atoms and molecules one by one, which gives us unprecedented precision and zero waste. On the other side, the top-down approach, etching and breaking bulk material down into nanoscale pieces. It's a bit of a brute force reductive process, sure, but it is currently the highly scalable foundation of our entire modern tech industry.
Now, what's really interesting to consider is that looking at the big picture reveals a shared destination. Whether you're painstakingly assembling atoms one by one or aggressively shattering a solid cube of bulk material, both paths are two distinct methods manipulating the exact same nanoscale world. Two completely different routes to the exact same invisible frontier. Which brings us to a fascinating crossroads. As we push the absolute limits of human creation, which approach will dominate the future of building our world? Will we perfect the industrial art of etching away the bulk, or will we master the godlike ability of assembling our reality atom by atom? It's wild to think about. Thanks so much for exploring this explainer with me today. Keep asking the big questions about our tiny universe.